3 plus h minus 3. As we expected, that leaves us the h in the denominator. Now, I need s of 3 plus h. How's your algebra? Do you see what to do with s of 3 plus h? Do you see that s of 3 plus h is 3 plus h squared times 16? Let me talk about that. I want s of 3 plus h. It is 16 quantity, 3 plus h squared. But you might be, so forgive me if I am belaboring the obvious, but I know that some of you have problems with algebra. So I just want to review this. When I say that s of t equals 16t squared, that's a function. And when I'm explaining functions, I think back in 7th grade, when they first were presenting this to you, they said, okay, a function is a set of instructions. Did they use a box? It's not such a bad idea. 16 box squared. A function is a set of instructions. You do s to whatever goes into the box. So if it's 3, if it's 4, if it's 17, if it's 3 plus h, put 3 plus h into the box. Put 3 plus h into the box. Are we okay? Here is on your exams. I get this. 16 3 squared plus h. That's what happens. People see the t squared and they put the 3 in for the t squared, and then they say, well, what should we do with the h? Let's add it on at the end. No, because you see what that is s of 3 plus h. That's a different creature. S of 3 plus h is different from s of 3 plus h. Very common mistake. So be careful, don't do that. So are you okay with the plug-in and now s of 3? Most everyone is happy with s of 3. S of 3, most people are happy with that. The mistake is the plus h goes inside the parentheses. And so now it's algebra. Expand the square. So that's the limit as h goes to 0 of. Let's expand that square. And again, I'm sorry, I'm blanking on her last name. This morning I ran into Marie.
Arvio.
Yeah, thank you. Yeah, I ran into Marie, who runs the Q Center. So the Q Center is where you can go and get some questions answered. Say if you find you're a little weak on some algebra. Q Center will open up this week where there are math tutors that you can go get help at. So do you all remember about expanding a square? A squared plus 2ab plus b squared. The mistake, when expanding a square, the mistake is too often people leave out the middle term, and that blows away the whole problem. So don't leave out the middle term. So the 3 plus h squared. So That's 3 squared plus 2 times 3 times h plus h squared minus 16 times 3 squared. Now, when you're doing this, you know, you call 3 squared 9, you call 2 times 3, 6, that's fine. Let me leave it unsimplified for a minute, because I'm sort of reviewing the algebra. So distribute the 16, 3 squared plus 16 times 2 times 3 times h plus 16h squared minus 16 times 3 squared all over h. And now you see the cancellation. 16 3 squared, subtract 16 3 squared. And now we just have 2 terms left. Let me recopy. And you've got this term, which is a 16 times 2 times 3h plus 16h squared all over h. And you look at those and you say, oh, there are 2 terms in the numerator that have a common h factor. I can factor the h out. That's the limit as h goes to 0 of. Factor the h out. Here you're left with 16 times 2 times 3 plus a 16h all over h. And now we use the limit thing. Remember, we're only taking the limit as h goes to 0. H is tiny, but it's not 0. You can't put 0 in for h because 0 over 0 is meaningless. Or, more properly speaking, 0 over 0 is ambiguous. And math hates ambiguity. So that's why math says 0 over 0 doesn't exist, because it's ambiguous. But because h is not 0, because h is not 0, it's only tiny. Now you can cancel the h's. So this becomes the limit as h approaches 0 of 16 times 2 times 3 plus 16 times h. Now you have no division. Now you can plug in. Now you can plug in h is 0 because you're not dividing by it. And so the only h here is 0. So you're left with 16 times 2 times 3, which is finally 96. Okay, now, I tried to write everything out in great detail. When you're doing the problem, I'm sure that you collapse some of these steps. You collapse some of these steps. 9, 6, and maybe once you subtracted these, you'd immediately go here. Maybe you didn't write out this step. That's okay. As long as your steps are accurate, you don't have to write everything out. But I'm still writing everything out, trying to talk about gross detail. Now, we're spending today, according to the syllabus, we're spending today and Wednesday on 3.2. We will. But I am so close at this point to the next section, 3.3, I have to talk about it. You know, we did this problem 11 here, where our time was 3. And you saw we had a 3 there, a 3 there, a 3 there, okay? I want to, and I realize I'm now talking about 3.3, but the work is all there. What 3.3 does is, instead of picking a specific time of 3, it says take any time. Leave the time arbitrary. Leave t as t and do the same work. And the steps are exactly the same. So if you're comfortable with 3.2, you're going to be quite comfortable with 3.3. It's exactly the same algebra. It's exactly the same steps. And let me do that now, even though I know I'm getting ahead of myself, but it's a good time to explain it. So again, S of t is this 16t squared. And I want to say find the instantaneous speed at not just t equals 3 or t equals 4, at any time t. Instead of plugging in 3 for t, just leave it t. And watch, it's the same thing. Here's your formula. This is the limit as h goes to 0 of s of t plus h minus s of t all over h. You see why? That's still the limit of distance traveled over time elapsed. Okay, I grant you. You can just memorize the formula. But I keep struggling with getting you to understand. Sure, you can memorize the formula, work the problem, and my fear is it's garbage in, garbage out. I want to always try and explain why this stuff is working. So you take your baseball, you drop your baseball, and here at time t, you want the instantaneous speed. So the idea is, think of the baseball dropping an additional 8 seconds from there to there. So the distance traveled, this distance here is s of t. That's the starting distance. The finishing distance is s of t plus h, because you do a little h interval. And the time elapsed, well, to go from t to t plus h, it's h. So you see why this is distance traveled over time elapsed. And then you take the shrinking interval. Make the interval get smaller and smaller and smaller. That's where the formula comes from. Okay? And now what we're going to do is apply the function s. I want s of t plus h. Are we okay? Can I use my childish boxes to be sure we're all together here? I want s of t plus h. Put t plus h into the box. The instructions say square it, multiply by 16. So this in blue is that in blue. Minus. Now usually people are okay with s of t. That's usually not a mistake. Because s of t is sitting right there. The idea is now put t in the box and you have 16t squared over t. So the first thing I did is I applied my instruction, I applied my function. Now take the limit as t goes to 0 of. Now you're doing, you expand your algebra. So, you know how to expand a square. T squared plus 2th plus h squared, right? A squared plus 2ab plus b squared. Now I'm going to distribute. So distribute that 16 across the parentheses. 16t squared plus 16 times 2th plus 16h squared minus 16t squared. Oh, I should have brought my h down. My h down. And you can simplify 16t squared, subtract 16t squared. I'm going to recopy, but maybe you would do this in your head, which is fine. 16 times 2th plus 16h squared over h. Maybe you wouldn't have to recopy that. That's fine, that's fine. And now you see I got two terms in the numerator. Factor out the h. That's the limit as h goes to 0 of. Factor the h out. You have 16 times 2t. Factor the h out. 16 times 2t plus 16h over h. And now I can factor the h's because h is not 0. It's tiny, but it's still a little positive number, so it's legal. So this becomes the limit as h approaches 0 of 16 times 2t plus 16h. And now you can plug 0 in for h, because you don't have division anymore. So that becomes 0, and this here is 16 times 2t, or 32t. So, let's see, I'm trying to put all this in. There was your original function, 16t squared. And there's a formula for instantaneous speed. Or instantaneous rate of change. This idea is extremely important. And as I have said, this is what economics calls marginal. Marginal cost, marginal profit, marginal revenue. That's all instantaneous rate of change. And because this idea, because this formula is so important, it's given a special name. It is called the derivative. So in a sentence you would say that 32t is the derivative of 16t squared. Yeah.
Can you take the power of 2t, take the power and then multiply that by 16 and get 32t from the beginning?
You're wanting to distribute the 16 in here?
No, but just in the start of the problem, like the 2t with the power of 2, can't you just take that, multiply that by 16 and get 32t like right from the start?
Okay, you've had this before, right?
What?
You've had calculus before.
No, I just,
Okay.
I saw online.
Oh, okay. I mean, what you say is correct, and we're not there yet. But let me repeat what you said. You know, if the problem had just been t squared, we will see the derivative is 2t. And by putting a coefficient of 16, coefficients we will see stay. Whether you take a derivative or whether you take an integral, whatever that is, coefficients stay. So therefore, you're absolutely right. It's 16 times 2t. Okay? But we're not quite there yet. But you're absolutely right. And so this idea of derivative, I admit I'm getting a little ahead of myself. This is what 3.3 is about, and we talked about this on Wednesday. But I was so close to it, I had to throw it in. And I just wanted to point out, again, from going here to here, I did it correctly, I hope, but there is a very common mistake when students go from here to here. And let me talk about it. There is an important algebra point here. If you've got AB plus AC over A, the following is correct. You can factor an A out and cancel with the denominator, so that equals B plus C. That is correct. Here's the mistake. I grabbed my red pen. People only cancel the first A. Same problem. But they canceled this A with that A, leaving that one. And so that's not right. Okay? Because what you're doing here, this step, you are distributing the A, distribute the H in this case, distribute the H out of both terms, and then cancel. You don't cancel, so you cancel factors, not terms. Here, it's like you're trying to cancel a term. Never, never cancel terms, only ever cancel factors. That's a very common mistake. And you can see how, since you're doing this often, you're gonna blow away a lot of problems. Now, for number 12, I got 5 minutes, and it's right here. For number 12, for the ball in exercise 11, find the instantaneous speed when t is 4. Well, you know the answer already. If t is 4, you know the derivative is going to be 32t. 32 times 4 is 128. You've already seen the answer, but let's go through the steps. Same steps we've been doing. So, 3.2, problem 12. You know that the instantaneous speed is the limit as h goes to 0 of s of t plus, instantaneous speed at time t is t plus h minus s of t all over t. And so here what problem 12 says find the instantaneous speed at t equals 4. So what they're wanting you to do, it's the same steps we were just doing. But it's okay. Let's do it again. Put 4 in for t. This is not a waste of your time. You're going to have to be doing these steps a lot. So the limit as h goes to 0, the first thing you do is apply s. You were told s of t is 16t squared. And only if it helps, do boxes help? If not, forget it. If you apply s, it's 16 box squared. This step is this step. Minus the green, which usually people don't have a problem with because they're putting 4 in for t. Okay, same steps. You need to expand your square. Are you okay with that? 4 squared plus 2 times 4 times 8 plus h squared minus 16 times 4 squared. If you called this 16, you called that 8, fine. I'm leaving it unsimplified because the point I just made is leave 4 up t, and it works out the same. Now distribute the 16. 16 times 4 squared plus 16 times 2 times 4h plus 16h squared minus 16 times 4 squared. And now you see your subtraction. 16 times 4 squared, subtract 16 times 4 squared. That's the limit as h goes to 0, recopy. 16 times 2 times 4h plus 16h squared all over h. Now, factor the h out of the numerator. So you're left with 16 times 2 times 4 plus 16h all over h. And now you're invoking, here's why we're doing limits. You can't divide by 0, but because h is not 0, might be tiny, but it's not 0, it is legal to cancel those non-zero terms, so this is the limit as h goes to 0, of 16 times 2 times 4 plus 16h. Now, no division, plug 0 in for h. And so that term becomes 0. And you're left with 16 times 2 times 4, or 144 feet per second. Your instantaneous speed at 4 seconds. So we've gone through the steps again, and we're going to be doing lots of these, and you're going to have bunches on the test, so be sure that you're comfortable with the algebra. So finish off 3-2 for Wednesday, see you Wednesday.